You know, sometimes it feels like geometry has its own secret language, doesn't it? Well, today, we're on a mission. We are cracking the code of one of the most fundamental shapes in the universe, the circle. We're going to unlock the powerful secrets hidden right inside it by mastering its key theorems.
So what are these secrets? Well, it turns out a circle is just packed with these elegant, totally predictable rules that govern every single line and angle. These rules are the secrets, and believe me, knowing them is a superpower. So let's get started.
Now, to crack any code, you got to follow two simple steps. First, you need to understand the language it's written in, right? Then, and only then, can you master the rules that connect all the pieces. And that is exactly how we're going to approach this.
So, first things first, let's learn the language. Before we can jump into the really powerful theorems, we need a quick refresher on the key terms. This is the foundation for, well, for everything else we're going to do.
First up, we've got the most basic building block of them all, the radius. It's just any straight line drawn from the dead center of the circle out to any point on its edge. Simple, I know, but it is absolutely fundamental.
Next up is a chord. A chord is any straight line that connects 2 points on the circle's edge. And here's a little fun fact for you. The longest possible chord you can draw is what we call the diameter, and it slices right through the center.
An arc is basically just a piece of the circle's curvy boundary. And here's a really key concept. An arc subtends an angle. That's a fancy word that just means it creates an angle from its two endpoints to some other point. Remember that word, subtend, because you're going to hear it a lot.
And finally, let's look at two types of lines that interact with a circle from the outside. You've got a tangent, which just kind of skims the circle, touching it at one single point. And then you have a secant, which cuts right through it, intersecting at 2 points. So 1 point versus 2. That is the key difference right there.
All right, we know the language. Now it's time to master the rules. Welcome to Level 1, where we decode the secrets of all the angles created by those arcs.
Our first rule has a great nickname. It's called the bow tie theorem, and you can probably see why. It says that if you have one arc, any angles it subtends to the circumference will always, and I mean always, be equal. It doesn't matter where you draw them. If they start from the same 2 points on that arc, they are identical. Okay, let's put that to a quick test. If this angle down here, created by the arc at the bottom, is 65 degrees, what is the second angle going to be? Yep, you got it. It has to be 65 degrees too. Same arc, same angle. Simple as that. Okay, let's move on to our next rule and see how these ideas build on each other. Now this one is super important. The angle an arc makes at the center is always exactly double, twice the size of the angle it makes at any point on the circumference. It's a perfect 2-to-1 relationship every single time.
And check this out. That last theorem basically proves another famous one. We know a diameter is just a straight line, right? So it makes a 180-degree angle at the center. And since the angle at the circumference is always half the angle at the center, well, what's half of 180? It's 90. And that is why any angle you draw in a semicircle is always a perfect right angle. Pretty cool, huh?
Level 1 complete. Now, on to Level 2. This is where we decode the rules for tangents and secants, you know, those lines that mess with the circle from the outside.
So here's a rule you can always count on. Wherever a tangent touches a circle, if you draw a radius to that exact point of contact, they will always meet at a perfect 90-degree angle. They are always perpendicular. This is a huge clue in solving so many geometry problems.
And here's a fun one, which I love. It's often called the ice cream cone theorem. If you draw two tangent lines from the same single point outside a circle, the lengths of those tangents, from that outside point to where they touch the circle, will be exactly equal. It creates this perfect symmetrical shape, just like an ice cream cone.
All right, you're doing great. Time for the final level. Let's look inside the circle and uncover the hidden connections between the shapes that form within its boundary.
So first, we need to meet a special kind of shape. It's called a cyclic quadrilateral. And it's really simple. It's any four-sided shape where all four of its corners, its vertices, are sitting right on the circumference of a circle. So what's the secret rule for this shape? Well, the magic number is 180. In any cyclic quadrilateral, the opposite angles are always supplementary. That's just a fancy way of saying they always add up to exactly 180 degrees.
Let's do a quick check. If this angle here is 70 degrees, what does its opposite angle have to be? Well, it's got to be 180 minus 70, which is 110 degrees. See? Easy as that. And one more really powerful internal rule for you. When any two chords cross each other inside a circle, they chop each other into two smaller segments. This theorem says that if you multiply the lengths of the two pieces of one chord, that product is going to be equal to the product of the two pieces of the other chord. So A times B always equals C times D. Okay, you've learned the language, you've mastered the rules. Now it's time to put it all together and pick the master lock. This last challenge is going to require you to combine a few of the theorems we've talked about. And here it is. We've got a cyclic quadrilateral with its diagonals drawn in. We're given two little angles. One is 55 degrees and the other is 45. Your mission, should you choose to accept it, is to find the value of angle x. Go on, take a second, think about which codes you need to use here. All right, let's crack this code together. Step 1, look for a bow tie. That 55-degree angle is subtended by an arc. And look, so is this other little angle right here. Thanks to the bow tie theorem, we know it's also 55 degrees. Okay, now we know the full angle in that top corner is 55 plus 45, which gives us a nice round 100 degrees. And for the final step, the cyclic quadrilateral rule. Angle x is opposite that 100-degree angle, so it's got to be 180 minus 100, and the solution is 80 degrees. See how it all just comes together? It's like a puzzle. And just like that, the secrets of the circle, they're yours now. You've seen how a few simple, really elegant rules can solve some pretty complex-looking problems. So the final question isn't really about memorizing theorems, it's about what you can do with them. You've cracked the code, so what are you going to build with it?